Okay, 2.7, one-to-one functions. And their inverses. Alright, so when we deal with functions, we had a vertical line test, and if the vertical line hit twice, then it wasn't a function. Now what we're looking at is whether or not a function is one-to-one. And the test for that is a horizontal line test. And what you really need to make sure you're asking yourself and use that brain that you have is this. Do two values of x, two different values of x, give the same y value. The same y. The two values of x, two different values of x. Do you get the same y value when you're done? So you're going to plug in two different values of x, and hopefully you'll get different values of y. If that's the case, it's one-to-one. If you get the same value of y, then it's not one-to-one. So for instance, y equals x squared is a parabola, opens up, and we'll just use the basic numbers. -1 and +1, does that give me the same y value if I plug those or substitute those answers in, those numbers in? -1 squared is +1, and +1 squared is +1. So two different values of x, and I get the same y. So this is not one-to-one. And it also fails the vertical line test, which is what we just showed. Or horizontal line test. Can you see it?
No, like this is not what?
Not one-to-one. Okay, so most of the time, the hardest part about this lesson is for students to really understand this question right here. And you have to actually think on some of these expressions when you substitute some numbers. What numbers can I use? You can use any two numbers. The question is, is there any way that you get the same value of y, the same answer, if you plug two different numbers in? Okay. So how about we look at this problem: y equals the absolute value of x. Can you think of two numbers that you could put in there and get the exact same value of y? Can you give me an example? If you just say, can you have a yes? 4 and -4. So those both give me the answer of +4. So this is not one-to-one. Okay. Let's talk about the inverse of a function. The inverse of a function. Basically, in general, and we're going to show this in the next few minutes with some examples, but f of x equals y. The inverse of that, and this is how you use your notation, the inverse of y is x. And what this is saying is, for whatever value of x I put in the function, I'll get an answer y. And if I find the inverse of that function, if I plug that y value into that function, I'll get the x value that I had started with. And we'll give an example here in the next few minutes that shows that works. Okay, so in general, this is what this is saying. So example, this is number 21 in your book. If f of 2 equals 7. What's the matter? Okay. When I substitute 2 into the function, I'll get my answer to be 7. That's what this is saying. So what we're saying up here is if I substitute 7 into the inverse of the function, or into the inverse, my answer should come out to be 2. So what's happening here? What do you just notice in general? Yeah, they're just switched. Okay? Right? That we said X and Y are switched? Yes. And that's important. So again, here's just another simple example. If the inverse of 3 is -1, then what is the function when it's -1? Three. And again, we'll do an example. Alright. Moving on. I want to get you to some better stuff here. Use the inverse function property to show that f and g are inverses of each other. And now you have the last section coming back to bite you if you didn't grasp it. F and g. We're going to do combinations of functions. Show that f and g are inverses of each other. Okay. Okay, so how do you show that two functions are inverses of each other? Well, you're going to substitute one function into another function. So let's say f of x is 3x and g of x is x over 3. To show that two functions are inverses of each other, you need to find f of g and g of f. Everybody do both of those. I want to see what you get.
It's like blurry.
Looks good now. While I'm up there, is it good?
More like something. Or like.
It helps to have a darker marker too. Alright, so who can tell me what f of g looks like? What do I need to do? What does this mean? Yeah, so basically it's just f of g of x. So f of g of x is x over 3. So I'm going to put that, or substitute that in for the x and f in the f function. So that's 3 times x over 3. And what do you get? X. 3x over 3 is just x. 3 is reduced. Alright, everybody do g of f. What?
You get x.
Get x again? Is that right? So g of f of x, or g of 3x. So we plug 3x in for this function, so we get 3x over 3. And again, the 3's reduce out. If you get x's for these, they have to both of them be x's, okay? Then these are inverses of each other. Okay, so to show that two functions are inverses of each other, you want f of g and g of f. As long as they end up equaling x, both of them, then they're inverses of each other. If they do not, then they're not inverses of each other. Everybody know what to do? This is an important part of this lesson. All of it's important, but this is a major piece. Okay? Alright. Let's do this over here. Alright, I'm going to give you some more steps in this next one to help you with your homework. Show you what to do. How to find the inverse of a function. Here you're showing that two functions are inverses of each other. How do I find an inverse of one function? Alright, so how to find the inverse of a function. Step one, which is really not a step, but we're going to write it as y equals the expression of the function. Basically, we're replacing f of x with y, just so we can look at it from a normal point of view. Step two, well, I guess we'll do an example along with this. This is example 40. F of x equals 3 minus 5x. So step one, we're just substituting y for f of x. So it looks like a normal equation that we're used to. Wait for you to catch up. Okay? Step two, everybody right now solve for x. Get x by itself. And then I'll do a more complex problem. Get x by itself. So, don't add 3. That's a positive 3, so we subtract it. Minus sign does not disappear. Write off the negative 5. Who got that? Okay, some of you are still working. Good. Step 3, last step. Interchange x and y. Or switch x and y. So x minus 3 over negative 5. Now I'm just going to put the y on the left side because that's where we're used to it. Okay. All I did was switch x and y. That's the last step. And then if you have a complex fraction like this, really, let's split it apart. What's the number in front of the x here? So this is really negative 1/5 x. And that's going to be plus 3/5. So negative 3 over negative 5 is positive 3/5. Okay.
How do you do that?
Put the negative 5 under each of the terms here in the numerator. So that's your inverse of that function. So if it ever asks you to find the inverse, this is how you do it. Solve for x, switch x and y. That's it. Really just 2 steps. Okay? Alright, so let's do a more difficult problem. What do we have? Let me pull a harder problem out because I want to show you some grouping information. 2-7. Let's do, example. How about 48? 48 is kind of ugly. 4x minus 2. This is f of x equals 4x minus 2 over 3x plus 1. What do I do first? I don't like fractions. And you have 2 different places where there's an x. So what we should do is probably get this x out of the denominator. And so how do you get your denominator to move? How do we do that? Multiply by. So we're going to multiply both sides by 3x plus 1. Okay, those reduce out, and on the left, I'm going to distribute and get 3xy plus y equal to 4x minus 2. So let me correct me if I make a mistake. Doing this on the fly. Okay, what's wrong with this one?
You can't do anything.
I have x on both sides, right? Yes, you can. I have x on both sides. Don't I need to get the x's together at least? Okay, so I'm going to subtract 4x to the left, and at the same time I'll subtract this y to the right. So I have 3xy minus 4x, and negative y minus 2. Alright, first things, let's just go back and mention what we did here. We had our x's in two different spots. We have one in the denominator, so to remove it, we multiplied by it. Then we had x's on both sides of the equal sign. We need to get them together so that when they are together, I can factor 1x out. And I get 3y minus 4 equal to minus y minus negative y minus 2. Now that I have 1x here, what do I do? How do I get rid of this parentheses? How do I get it away from the x? How's it attached to the x? So what's the opposite of that? You can't divide it off. You guys are scaring me. So here we have x equals negative y minus 2 over 3y minus 4. So it took a lot to solve for x. This is one of the more complex ones. Okay? So now, step 3, switch them. So we have y equals negative y minus 2 over negative x minus 2 and 3x minus 4. So my inverse is that. That's how you find the inverse. Solve for x, switch your x and y. Any questions on that? Pretty easy when it looks like this. A little difficult when it's like this. All right. You want something easy? Yeah. Okay. How to graph. What's wrong with graphing?
What's not wrong with that?
Oh, come on, I'll make this easy, okay?
Okay.
Alright. How to graph the inverse of a graph. Okay, given a graph line or segments, give me the inverse graph of it. So here we have a function, and okay. Here you get a function, and we taught you how to find. She got hit by a soccer ball. Relax. Here we got a function, and this teaches you how to find the inverse of it. Here I'm going to give you a graph. You got to give me the inverse of the graph. All right. So I'm just going to put it up here, and we'll see if you guys can figure it out by what I'm doing. All right. So everybody draw this. It'll be in the first quadrant. This example. The others aren't necessarily. I'll give you a couple examples here. All right. My first point is at 0, 1. My second point is at 4, 6. And my third point is at 8, 8. Alright. So there's the graph of those two segments together. I want the inverse of that graph. I'm going to draw it, and then you see if you can figure out what happened. Yes, ma'am. Yeah. 1, 0. 6, 4. 8, 8. How's that? Alright, let me make it hard.
No.
Alright, let's try this. Here's the, well, I don't, that's really all you're doing, okay? I just want to draw something different so that when you see something different, you're like, well, that's not exactly what it is. You weren't given curved lines. I want something like this. Here's your function, f of x equals the square root of x plus 1. Somebody tell me where that starts. Where does it start by looking at it? Yeah, left 1, right? Correct? Left 1. So it starts here. When x is 0, I'm just picking some points here to graph this. When x is 0, the square root of 1 is 1. When x is 8, 8 plus 1 is 9, that's 3. Okay. I want the inverse of this. So what are you going to do? Yeah, switch to x and y. Okay, so tell me how to do that. Instead of -1, 0, 0, -1, thank you, now do the rest. The second one should be where? 1, 0. And the last one should be 3, 8. And there's your inverse graph. Now what if I'd say I want to know the actual inverse function of this? You gave me the graph. What's that going to be? How do you do that? Step 1. Step 2. Solve for x. How do I solve for x? What? Square both sides. Y squared equals x plus 1. Now what? Get x by itself. This is algebra, guys. Subtract 1 for both sides. Y squared minus 1 equals x. Now you got x by itself. What's step 3? Switch them. So x squared minus 1 equals y. So that would be my inverse function, kind of.
What would the points be for the inverse of my graph?
What's that? This is a parabola. If I were to draw this, it would look like this. Okay. But that would not be 1 to 1. Okay. So I only wanted this part. So I have to put this little limitation on here. So if you see this stuff, that's just saying, okay, if they didn't have this on that problem, then it probably wouldn't be 1 to 1. So you need to be prepared to look at that and say, okay, what range, what domain am I talking about? And that's why I put that on there. Okay. Otherwise, if I don't put this here, then this really doesn't look like the inverse of that, because it would be the other side as well. Okay, that was just a harder one, that's all. Okay. All right, beat 'em. Page 205. 5 to 81, every other odd. 5 to 81, every other odd. Okay. Begin.
What was the video for?
Out of space for the edgy creation stuff. I could have pulled this down and videotaped that, but they haven't gotten me the pro version of it yet. And I still think we'll run out of space, but I'm going to videotape it even if I do it on Edgy Creations. The Edgy Creations allows you to download it off of Edgy Creations. Right now it won't let you do that. You have to be part
So
of it.
is that like if we're absent or if we forgot kind of what you said?
Yeah. Now, you guys don't know.